Okay, good morning, Year 11. Today we're going to be looking at natural hazards in the context of weather hazards in a much less exciting way than we've been looking at for the past few weeks of tropical storms. We're going to look at UK weather hazards. A selection of pictures. Pause this presentation for a minute, see if you can work out what the extreme weather is that we even get in the UK. It's far less exciting than the stuff we've been looking at the last few weeks, but stuff you should be familiar with seeing on the news. See if you can work out what any of them are, and then press play again when you've had a little look. So, just a brief recap. Remember when we're talking about weather hazards and climate hazards, they are not the same thing. The weather of somewhere is the day-to-day conditions. So when I'm looking outside my window today, it's pretty grey, not particularly sunny and very cold compared to the last few days. The climate, however, is what it's like over a longer period of time. So for the UK, for this time of the year, so the start of spring, it's usually about 8 degrees and there is usually a bit more sunshine than we've had than today. So weather day to day changes really frequently. Climate, what is the overall average conditions for this place at this time of year? Now, if we have a look at the climate graph of London, you can see we don't have huge amounts of variations in the amount of rainfall that we get. So if you look at these bars, remember when we do climate graphs, the bars are precipitation, the rainfall, and the line shows temperature. We have a relatively stable amount of rain, but we do have fairly big fluctuations in temperature. So we go from about 3 degrees in January all the way up to about 23 degrees in the summer. Now remember, this is London in the southeast. So the southeast is obviously the warmest part of the UK. It's a little bit closer to the equator, albeit only very marginally. But we do get warmer weather here than if this was a climate graph for somewhere in the north. And it would be obviously a lot colder and most likely have a fair amount more rain, especially if you were somewhere a bit more mountainous. But we can see here nothing's particularly extreme. We don't have huge variations in our rainfall. We do have a bit of variation in our temperatures, but we have 4 seasons, none of which are massively different to each other. So when we talk extreme weather in the UK, we're not talking that extreme. So the extreme weather that we really have is heavy rain and strong winds. We've experienced both of those quite a lot, not so much over the last few weeks, but certainly over the winter period, we have experienced a fair amount of wind and rain. And that is because our weather predominantly is blown up towards the UK by southwesterly winds. So you can see over here, we have storms from the Atlantic, which bring heavy rain and strong winds. But as well as that, because we are in between weather fronts, we sometimes get hot and sunny weather from the Mediterranean, from Spain and from Italy, which can sometimes bring us summer heat waves and droughts, which we have also had over the last few years. Again, we can also have Arctic air coming down from the north, bringing us snow, not so much at the moment, but we have had some fairly large periods of snow over the last few years. And we can also have our weather coming from the east, from kind of Scandinavia and Russia as well, which can provide a lot of cold weather, wind, and sometimes some snow, especially if you live in the north and in Scotland. So what I would like you to do for your first activity today is I would like you to use pages 32 and 33 in the textbook, and I would like you to please have a go at making a mind map, spider diagram, whatever you want to call it, that contains the main types of extreme weather we have in the UK. So they are thunderstorms, prolonged rainfall, drought and extreme heat, heavy snow and extreme cold, and strong winds. And just a little bit, couple of sentences of detail about each of those, please. So pause this video, have a go at that. It shouldn't take you more than 6 or 7 minutes, I would say, and then hit play again. Okay, so just as a reminder about what the UK's climate is like, remember we are located just beneath the 60-degree line of latitude, which means that we get both cold weather coming down from the North Pole, and we get warmer weather coming up from the feral cell in the middle, and we get warm subtropical air moving up from the south. So because of that, we are in between two different fronts, and that means that we do experience a lot more rainfall than areas that are closer, like kind of further south than us. So France and Spain, we do get a lot more rainfall than there, as I'm sure you will be shocked to find out. So this is why it is always raining in the UK. Can you now please just pause this video, have a go at one of these 3 levels of challenge to explain to this poor man why the UK receives so much rain. So if you're having a go at the hard activity, that's in 1 sentence. The harder one, 2 sentences, so more detail about the fact that we're in between 2 fronts. And for the hardest level of challenge, which I expect a lot of you to be having a go at, 3 or more sentences, so a full meaty paragraph explaining why we get a lot of rainfall in the UK. So moving on to our case study. So this is our final case study of GCSE geography, final geography case study at all for some of you. We are going to be looking at the Somerset levels. So for those of you that don't know where Somerset is, it's kind of in the southwest of the UK. It's quite a flat area, and it's an area that gets a lot of rainfall and therefore suffers a lot from flooding. So the next thing I want you to do, please, if you can, and you have a printer at home, could you please print this particular map? So just snip it out from the PowerPoint, and I would like you to print it out and then annotate for me. Can you spot anything on here, any evidence that might suggest that this area could experience a fair amount of flooding? So what are the things that you're going to need to be looking for? Remember, for a flood to happen, you need to have a river. And as well as that, thinking right back to year 7, where most of you would have last studied rivers, or possibly in year 10, if we can remember that far back. What is the shape of the land like here? And we're looking for those orangey contour lines. We're looking for whether it's in a steep valley, whether it's in a flat area. Which particular parts do you think are likely to flood the most? And annotate on your map for me some reasons why you think that this particular area, called the Somerset Levels, is at risk from flooding. And if you need a little bit of a hint, you could have a look at the first paragraph at the top of page 34 in the textbook. That will help you. Okay, so Somerset Levels are prone to flooding because of a number of different reasons. The first being that the Somerset Levels kind of border onto 2 particularly hilly areas. We're not talking huge mountains, they're not like the Lake District, but there are the Mendip Hills, and we also have the Quantock Hills, which kind of sandwich either side this area, this kind of green area here, where the Somerset Levels are located. So it's sandwiched between hills. That therefore means that any rainfall that happens in those hilly areas is going to run straight over the top as surface runoff, and it's going to end up going into the bottom of this valley here. As well as that, those of you who are more observant will notice that there are 4 rivers. Now, 4 rivers with a lot of tributaries, if you see these small kind of branches, means that there's a lot of water flowing through this area anyway. And 4 rivers means you've got 4 times as much chance for this area to flood if those rivers can't cope with the amount of rainfall that they are getting. So it's kind of a perfect storm. All we need is some heavy rainfall, and this area is not going to be able to cope with all of that water that's flooding into those rivers. So remember that we are sandwiched between a low pressure and a high pressure area. We are 5 degrees away from that next kind of cell, and that therefore means that we get a lot of frontal rainfall, where you essentially have hot air meeting cold air, and that therefore means that the warmer air condenses very quickly, forms into rain droplets, and that rain obviously has nowhere else to go but fall over the UK. So we get huge amounts of rainfall in terms of both slow and steady consistent rainfall, but also really heavy downpour events, both in the summer, but mostly over the kind of late autumn, winter time is when we tend to get most of our flooding. So in the year that this happened, so in 2014, it was the wettest January since records began in 1910 because of a series of areas of low pressure which had been brought over the Atlantic Ocean, and that brought huge amounts of rain, 350 millimetres of rain in January and February, which is about 100 millimetres above the average. So as we looked at the map, all of that rainfall has to go somewhere, and it can't go into those rivers at a speed that those rivers can cope with it, that they can push it out into the sea. So we obviously had some pretty huge flooding happening here. Combined with that is the fact that if we look at this map here, which is quite a weirdly complicated looking map, essentially what this map is showing us is that all of the rock underneath these areas is something called mudstone. And mudstone, called siliciclastic argillaceous, you don't need to know that. I can't even say it, so you definitely don't need to know it. It's basically a very impermeable rock. So it holds water. It doesn't allow water to absorb through it. It gets saturated very, very quickly, and it's almost kind of like clay, just sits there saturated, doesn't let water flow. Instead, it just sits on the surface, and therefore most of the rain that fell didn't absorb into the ground. It sat there and it flowed over the surface as surface runoff, and it did not end well for this area, as I'm sure you can imagine. Rivers hadn't been dredged either, so dredging is where we go through the rivers and we clear them of sediment. We can't get big diggers in, scoop out all of the silt, the sediment, the rocks and things that are in the bottom, and it meant that as well as having to cope with all that water going into the river channel, there was also a load of other gunk and stuff that would mean that it couldn't hold as much water. And it basically added to the fact that the relief, the shape of the land was perfect for a flood. The four rivers all combining was perfect for a flood, and the heavy rainfall meant that this was kind of an inevitability. More maps here. You know I love a good map, especially if they're nice and colourful. Blah, blah, blah. So these blue areas that we could see here during the flood event were what we call standing water. So essentially the ground was literally just covered in several inches and in many places feet of water. Turquoise was bog. What a lovely phrase. So that's basically where the ground had become so saturated that if you stood in it, water would just kind of rise up around your feet. So not much better than standing water, basically. So it was not a good time for the people living in these parts of Somerset. As well as this, we also had high tides and storm surges. So just to kind of add insult to injury, with the heavy rainfall also came very heavy, strong winds. And those strong winds swept water up the river. So as well as the water trying to be pushed out into the sea as it normally would do, the sea was pushing water back up into the rivers, and prevented the rivers from being able to push the water that they've got out into the sea so they could get rid of it and therefore take in more water from the rainfall that was happening. So this kind of all combined to mean that it was going to be an absolute disaster. So effects then, what are about to come up on the next few slides are a lot of the different effects that happened chronologically, hopefully, if I've put the slides in the right order, between the end of December and the middle of January. So this is how the flood affected different people. Now, there's a huge amount of information here. You do not need all of the information on these slides, but I've provided you with a lot so that you can pick and choose the bits that you need, the bits that you think are important. And I would like you to use this information to fill in the A3 sheet that I'm also going to attach to this homework. So you ideally need at least 2 or 3 items in each box. So you're going to need to categorise the impact into social, economic and environmental, and then use this information to fill in those particular boxes on the sheet. So I'll just whiz through them really quickly. We've got some of the responses included here as well. Some nice little, talking about Marie here. Oh, Anne Marie had to be rescued via a boat. Got some people there. Oh dear, I think that's a. And another one of the responses being that the fire rescue service had to pump water out into nearby fields, but as you can see, the nearby fields look pretty boggy already, so there wasn't a lot that they could do about it. Were involved, and we had continuous flooding. So whilst the flooding had already happened, it kind of continued happening over a series of a really long time. So we're now into the start of February. We're having people slagging off David Cameron, who was the Prime Minister at the time, saying that people should have been evacuated and they didn't evacuate. And finally, into March, where recovery is kind of finished, but they're now talking about what they should do in the future, because remember that these types of flood events are becoming increasingly common. Global warming, which is what we will look at in the next few lessons, is a thing. We know it's a thing. We know it's mainly caused by what we call anthropomorphic impacts, so people essentially. We know that floods are linked to climate change because climate change is changing weather patterns and therefore bringing heavier rain to places like the UK. So we can't just think about how we deal with this flood, but how we prevent future flood events doing as much damage as this one has done, which is a lot easier said than done. So what I would like you to do is I would then like you don't need to do this particular activity because you've already filled in your A3 sheet, but perhaps if you're missing any bits of information from any of your boxes, you could steal it from some of these bits of information. And then I would like you to just make sure that you've got all of the information you need to fill in your A3 sheets. Have a look at this picture. So this is one of the common things that they do to reduce the amount of flood water. What are some of the problems with this? Do you think you could use this everywhere? Do you think it's easy to do? Have a think about what might be some of the issues with dealing with events like this, especially in the context of the fact that we're going to have more and more of these in the UK. So that in a very short, sharp 17 minutes is essentially what you need to know about extreme weather in the UK and the Somerset Levels flooding case study, which is your final case study. I will see you after Easter for the last couple of lessons where we will look at climate change and the link between climate change and our extreme weather. As always, if you've got any questions, send me an email or a carrier pigeon if you're so inclined, and stay safe.